Alright, we are going to check our daily math. So I need all computers closed. And I need all attention up here. All computers closed, all papers put away, and all eyes up here. Okay. The first question that you had today on your daily math was to find the model that showed the fraction, the equivalent fractions 1/6 and 2/12. What does equivalent mean, Olivia?
Equal to.
They're equal. So for two fractions to be equal, can my whole that I'm comparing be different sizes? Can I compare a large pizza and a medium pizza?
Yes.
No. If I have two slices of a large pizza that are cut into 12ths and one slice of a medium pizza that was cut into 6ths, are my pieces going to be the same? No, because the whole thing was two different sizes. So the first thing we have to check when we're looking for equivalent fractions is to make sure that the wholes are equal. And in all four options, do we start out with the same size circle? Yes. So now I'm looking for the fractions 1/6 and 2/12 to show that that equals the same amount. Which one is it, Alexis?
It's the third one.
It's option 3. In option 3, we have one piece shaded in that first model. There are 6 pieces in the whole. And if I look at the second model there's 2 pieces shaded. And in the whole thing, there are 12 pieces. And I can tell by looking at what's shaded that that's the same amount. So if I think of those as pizzas, that's what I think of when I see a circle cut into pieces like that. That's kind of what I visualize. If I had this pizza, this 1/6 size piece, and Ansley had 2 12th size pieces, would we have the same amount?
Yes.
Yes, we would have the same amount of pizza, even though she has 2 slices and I have 1 slice.
It's just because yours is a cut.
Yeah, because mine's 1 piece, but my piece is bigger than her 2 pieces.
Yours is double the size of one of hers.
Exactly. Mine's double the size. You're exactly right about that. Okay, let's look at this next one. Which model correctly solves the problem? So we've got some fractions to add. When we're adding fractions, what do we look for to make sure of first, Amy, before we can add or subtract? We're finding the sum, but before we can find the sum, what has to be true? What has to happen?
That it has to add together to make it.
Okay, but before we can add, what do we have to check to make sure of? Keith, before I can add fractions, what do I have to check?
You have to check the bottom numbers to see if they're the same.
Exactly, I have to make sure that my denominators or my bottom numbers are the same. Okay, always have to check that. And in all 4 options, that is true. Alright, so first we have 9/10 plus 5/10. Cash, what is 9/10 plus 5/10?
14.
14 what? Tenths. So can option 1 be correct? No, option 1 cannot be correct because it says 13/10. So if I look at option 2, I have 9/10 plus 5/10 equals 14/10.
Yes.
That's true. So if I take the 14/10 and I break it into the parts to make a mixed number, how many of those 14/10 would I have to take out to make one whole?
4. No.
I'd have 4 left. How many does it take to make a whole?
10.
10/10 makes one whole. I would have 4/10 left. So based on the number bond that we just made,
1 whole.
We know 10/10 is 1 whole. So that is equal to 1 and 4/10. So our mixed number is correct. Let's check our model. Do we have 1 whole? And then we have 4/10 in the second model. So option 2 is our correct answer. What's wrong with option 4?
It says 9 plus. It says it's 11, but it's actually 14. It says 7. Well, but it says 9 plus 7, and that doesn't equal 14.
Yes, exactly. In option 4, we have 9/10 plus 7/10, and 9 plus 7 is 16, not 14.
Right, but then I saw the 7, and
Yeah, that's what was different about option 4 than 1, 2, and 3, is you were adding 7/10 to 9/10 instead of.
That's how that one was easy for me, because all the others didn't equal 14.
Exactly. You're exactly right. All right. Questions about that one? Let's look at our next problem.
I got this
All right. This next one we have some multiplication to do. 2-digit by 2-digit numbers. First we have 75 times 49. So if I draw an area model, one side of my model is going to be what? Dylan, what's the long side of my model going to be?
75, and then the short side is going to be 49.
Alright, so if I want my long side to be 75, how am I going to break 75 apart so that it will make it easier for me to multiply?
Split in the half, and you put 70 in one part, and then 5 in another part. And then for 49, you split in half another way, and then you put 40 in one part, then you put 9, and then you put 9 in the other part.
Exactly. We're going to make our long side 75. So I'm breaking that into 70 and 5. If I add 70 plus 5 together, does that make 75?
Yes.
Yeah, and 75 was one of my factors that I'm multiplying. And then on the short side, I'm going to make it 49. So I'm going to break it into 40 and 9. If I add those together, does that equal my other factor of 49?
Yes.
Does it matter if I switch my 5 and my 9?
No. But yes.
Yeah, it does matter. The whole point of an area model is that one side equals one of my factors or numbers I'm multiplying, and the other side adds together to equal the other factor.
If you swapped them around, it would be 45 and
Yeah, then
79.
exactly. I'm multiplying a whole different problem. So you have to make sure you keep those together. All right, so to find the area of this section right here, this first one, what am I going to multiply, Ansley?
70 times 40.
70 times 40. And what is 70 times 40?
2,800.
Very good. 7 times 4 is 28. And I have 2 zeros. All right. How about the area of this part, Scotty? 40 times 5. And what is 40 times 5? 200. Very good. 4 times 5 is 20. And I need one more zero. Okay. How about this part right here? What am I going to do, Jacob?
You are going to multiply 9 times 70.
9 times 70. Very good. Which is?
630.
Very good. 9 times 7 is 63. I need one zero, so that makes 630. And what am I going to need for this part right here, Alexis?
40.
What am I multiplying?
9 times 5.
9 times 5. Do 9 times 5 one more time. What is that?
45.
45. Okay, so I've got all 4 of my parts.
Miss Whitley,
What am I going to do now, Christopher?
you're going to add them all up together.
I'm going to add them all together. Did you have a question?
Yeah. If you switch the 9 with the 5,
Mm-hmm.
would it still equal the same answer?
You found that out earlier when you were doing your work, didn't you?
That's what
This is the same.
I got the...
But would this be the same?
No.
Mm-mm. Would this be the same?
No.
No. All right, so I notice when I go to add these, if I add 2,800 plus 200, what do I get?
3,000. 3,000.
Yeah, that 800 and the 200 equals 1,000, which would make that total
I didn't see the 2.
be 3,000. Okay, so now I can add 630 and 45. That makes 675. And then if I just put those together, my answer will be 3,675. Okay, I think most of you who messed up on that the first time fixed it whenever you redid it. You found your error.
Yeah.
Okay?
I actually didn't put the 0 on the 60. I missed the second one.
It's really, really, really important that we can multiply 2-digit by 2-digit numbers. That there's no excuse now for us not to be able to do that.